Hello Year 4 and welcome to your math lesson for today. In today's lesson we're going to be focusing more on subtracting fractions, but we're really going to think about those whole amounts today and how we could use bar models to subtract from whole amounts. So you have your daily fluency questions here. Can you please spend 3 minutes answering these now please? Pause the video, off you go. Okay, question number 1. What is 3/8 more than 7/8? That is the same as 3/8 add 7/8, giving us 10/8. Number 2, we can see that 3 is equivalent to 7 3 times. That would be 21 over 7. Subtract 5, giving us 16/7, or you could convert this into the mixed fraction, which would be 2 and 2/7. And finally, we can see that this side equivalents to 5,000 metres, which would be 5 kilometres. So 4 kilometres is less than 3,000 metres, add 2,000 metres. Well done if you got all those right. I do have some more questions just to warm your brain up for today's lesson. So could you please pause the video and answer these now? Off you go. Okay, how did you get on? 8/8 subtract 3/8 gives us 5/8. 9/12 subtract 5/12 gives us 4/12. 7/9 subtract 2/9 gives us 5/9. And finally 18/9, well, we know that this 1 represents 9/9. So that would be 18/9 subtract 9/9 equals 1 or 9/9. Number 2, we are looking at the difference between this fraction and this one. We can see that this fraction has been split into 7ths and this fraction is in 2. So the difference would be 5/7. And finally 5/6 add 3/6 add 1/6 gives us 9/6. But converting that into our mixed number, it would be 1 and 3/6. We could then find an equivalent fraction to this, which would be 1 1/2, because we could divide both of these numbers by 3. 3 goes into 3 once, 3 goes into 6 twice. Well done if you got those right too. Now today we are looking at subtracting from whole amounts. So you can see that I've got the sum on here, which is 2 subtract 5/8. Now, we are going to think about our bars to try and work this out. If we know that we are going to need 2 wholes, which is 2 bars. Now, thinking about my denominator, what are each of these bars going to be split into? That's right, they're going to be both split into 8. Now we know we are subtracting 5/8, so we don't need to split the second bar just yet. We can just split the first one into 8s. We can then find and cross out 1, 2, 3, 4, 5 8s and then count how much we're left with. And we can see we're left with 1 whole bar and 1, 2, 3 8s remaining. Let's have a look at another example then. So this one is 2 subtract 10/8. So again, starting with our 2 wholes, what are we splitting each bar into this time? That's right, we're splitting it into 8s again. Now we are going to count back in our 10/8, but we know that this bar, the whole, is how many 8s? Yes, well done, the whole is 8 8s. So that means we actually need to split the top bar into 8s, 2 this time. How many more 8s do we need to cross off if we've already subtracted 8 8s here? That's right, we need to subtract 2 more 8s. So now we have got 2 wholes, subtract 10/8 gives us 1, 2, 3, 4, 5, 6 8s remaining. Could we find an equivalent fraction from this? Do any multiples go into these numbers? Yes, 2 does. 6 divided by 2 is 3 and 8 divided by 2 is 4. So 6/8 is equivalent to 3/4. What I would like you to have a go now is have a go at this one on your own. Can you pause the video, use the bar model to help you please? Off you go. Okay, how did you get on? Did you start by drawing your 3 bars? And then you can split one of your bars into 8s. If I had 2 10/5 that I am subtracting, how many would I split my bar into that time? That's right, I'd split it into 5ths, wouldn't I? But because my denominator is 8, that means I'm going to split it into 8s. And I can start by crossing out 8 8s. Do I need to split another bar? Yes, I do. And I need to cross out 2 more 8s, which shows me that I have crossed out 10 8s because 8 8s add 2 8s is 10 8s. And I can see that I have 1 whole and 6 eighths remaining. And we could equivalent that to 1 3/4 because we know 6 eighths can be equivalent to 3/4. So well done if you got that right. We're going to take a closer look at this subtraction sum now. 3 subtract 10 eighths gives us 1 6 eighths. Now, we're going to show how we can use a part-whole model to work this answer out. And instead of crossing out the 10 eighths this time, we can just split the first whole into eighths and just simply colour them in to represent the 10 eighths. Similarly, on the screen in front of you, you can see that I've done that there. The bits that I've shaded in green represent my 10 eighths. And then I can show that on a part-whole model because my whole is 3. And I can see that the 2 parts that make my whole of 3 are in orange and green. I can see that one part is 1 6 eighths, which is my orange. And my second part is 10 eighths. But we know that 10 eighths is an improper fraction. What would the mixed fraction be? That's right, it would be 1 2 eighths. So I can see that 1 6 eighths and 1 2 eighths equals 3. Well done. We can also use finding the difference to work this out here. Thinking about what we did on Friday, all about finding the difference, can you pause the video and have a think? How would you find the difference between 3 and 10 eighths? Pause the video and have a think. Okay, some of you might be thinking that's a bit tricky, but let me show you because it's not as tricky as you think. We are going to have our 3 holes to start with, but this time they're going to be next to each other rather than underneath each other, and you'll see why in a little while. Then underneath that, I can make 10 eighths with my bar too. And I can see that the difference between this part to this part would be my answer. That is where I'm finding the difference, so you can see there. What I can then do is find out the difference by counting how many holes and how many parts that I've got left. So I can see I've got 1 hole, 1, 2, 3, 4, 5, 6 eighths, which is how I can arrive at my answer too. Can you have a go at questions 1, 2 and 3 on the worksheet, please? Pause the video now and have a go at those for me. How did you get on? I'm sure you were fantastic. Now, Tiny has given us a sum here and he says that 3 subtract 2/3 equals 1/3. Do you agree with Tiny? Pause the video and have a think. Okay, maybe you do agree with Tiny, maybe you don't. Let's have a look what Tiny has done. So we know that we are starting with 3 holes and we've got them there. What we could do is we could use the part-whole method to actually colour in 2/3, which is what we've done there. So we've subtracted 2/3 just by showing that that's what it is. And if you wanted to cross them out, you could do that too. We can see we are left with, when we have subtracted these 2/3, we are left with 1, 2 holes and 1/3. So actually the answer is 2 holes and 1/3 rather than just 1/3. Tiny had forgotten to count the holes. I've got a question for you to have a go at now. This is a problem-solving question. Can you read the question and then have a go at finding the answer? Pause the video and have a think. Okay, was that a bit tricky? I bet it was, and I bet you were fantastic. Rosie has 3 chocolate bars. She gives 5/6 of a bar to Tommy, 1/2 of a bar to Eva, and eats 1/6 of a bar herself. How much chocolate does she have left? Well, what we could do is we can start putting 1 chocolate bar next to each child to represent the 3 bars, okay? Now we know that Tommy gets 5/6 of a bar. So how much is this bar going to be split into? That's right, it's going to be split into 6. And we can cross off 5/6 to show that Tommy has had 5/6. Now Eva has 1/2 a bar. Now if 1 bar is split into 6, we know that 1/2 of that bar would be how many 6? That's right, it would be 3/6. So Eva had 3/6 of a bar because that is equivalent to 1/2. You can see that she has had 3 pieces and there are 3 pieces left. That's 1/2. And finally, Rosie eats 1/6 of a bar herself. So we can put that into our sixths, and she only has one of those sixths. She is very generous that she gives all of that to everyone else and only has 1/6. But the rest of the chocolate is hers. How much is left? What we can do is we can count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9/6 is remaining. Why have I not counted the squares that have been crossed out? That's right, because they've already been eaten. So 9/6 is remaining. Could we convert that into a mixed fraction? How many wholes would we have? That's right, we would have 1 whole and 3/6. Could we make an equivalent fraction? Does 3/6 go into anything? That's right, the number 3 can go into each 3 and 6, and that would be 1½ bars remaining. Can you now have a go at the rest of the questions on the worksheet, please? Pause the video and come back to this when you've done. You have worked so hard so far. We have got 2 more questions to go and then it's the end of the lesson. So the first problem solving question is using the bar model. So we've got 2 wholes here. Create a subtraction calculation where an improper fraction is subtracted from a whole number. What's an improper fraction again, year 4? That's right, an improper fraction is where the numerator is larger than the denominator. So could we subtract 8/9 from 2? No, we couldn't, could we? Because that's not an improper fraction. Could we subtract 9/9 from 2? No, because that's not an improper fraction either. That's 1 whole, isn't it? 9/9. What could we subtract from 2 that is an improper fraction? Maybe we could subtract 10/9 from 2. Maybe we could subtract 11/9 from 2. Let me show you how I do that. So I've got my 2 wholes, and then I can cross off 11. So I can see that I have subtracted 11/9. How many ninths do I have left? I can count them. 1, 2, 3, 4, 5, 6, 7/9 remaining. That's not the only one you could do though. You could have chosen to do 2, subtract 10/9 equals 8/9, or 2 subtract 12/9 equals 6/9, or 13/9 equals however many ninths, okay? So that is really making sure you read the question. If it's asking you for an improper fraction, your numerator must be larger than your denominator. Final question then, reasoning now, circle the odd one out. So we got A, B and C. They are all subtractions. Some of them start with whole numbers. Right, A. 5 subtract 4/7. What on earth? Well, we know that 5 wholes would be equivalent to 35/7, because that is 5 times 7 given us 35/7. So 35/7 subtract 4/7, we can work that out now. 35 subtract 4. That's right, 31/7. Similarly with B then, this time we have 6 wholes. What are we going to do now? So we know that 6 wholes could be the same as 6 multiplied by 7 over 7. 6 multiplied by 7 would be 42/7. 42/7 subtract 4/7. What's 42 subtract 4? Someone help me. Thanks, Ibrahim. 38/7. Well done. Finally then C, we do not need to change any of these whole numbers into fractions because we have 42/7 subtract 4, which is, well done Natalia, you've got it, 38/7 again. Which one's the odd one out then? A is the odd one out, well done. Why is A the odd one out? We need to explain our reasoning. Why is A the odd one out? Maybe A is the odd one out because that is the only one that equals 31/7. B and C both equal 38/7, and that is what our answer would be. Your task now is to complete either, you don't have to do both sets, the blue section or the orange section. Bearing in mind the orange is slightly more tricky, so see how confident you feel. Remember, when it says to explain your reasoning, what's your magic word? Because. Fantastic, well done. You have listened so beautifully today. Have a fantastic rest of your day, year 4. Bye.